All right, we're almost done for the day. What I want us to finish on is the system schemas and force diagrams we're going to make for these interactions. So I'm back on the interactions lab, and I just want us to go to the right of these objects, and we're going to make what I call a system schema. So all these forces we talked about are going to pop up on our system schema, and I'm going to go slowly. I'm going to do, I'm going to do probably 3 of these, and then I'll let you guys either practice more on some. Hopefully I can fit this all in one video. So I'm back on the interactions lab, but I'm going to be referring to these common types of forces. So my suggestion is maybe you should, just be ready to go back and forth, and let's work on this. So, all right. First one here, interaction 1, block and table. So I'm just going to draw what that looked like again, just for my own visual. You can look at the photos, but all right, we have this block on the table. So what is causing interactions here? Well, I know there's a block. So I'm going to make a bubble for the block. And people call these system schemas bubble diagrams because there's a lot of bubbles involved here. So I know the table's here, and I know the block is there, and I know there's a table. So then we have to ask ourselves, what is happening at this interaction here? This interaction here, the block is in contact with the table. So I'm going to look for any forces that match that. Okay, normal force, perpendicular to the contact surface when 2 objects touch each other. All right, Fn seems like it matches. So the block is putting a force onto the table. Well, if y'all remember what Newton's third law is, I'm going to go back. Newton's third law, every action has an equal and opposite reaction. Whatever you put for this arrow going one way, the table puts an equal and opposite force back. So what this is looking like is the block pushes down to the table pushes back up. So let's say this is a force normal from block to table. This one is force normal table to block. They should be the same size. The only thing different is they're going the opposite direction. All right. So, and if I look at this, I ask myself, like, are there any other forces I can detect? I don't think there's a friction. They're not trying to move. No spring, no tension, no apply. There's no person. Gravity, which is weight. Wait a minute. This block definitely has weight, but what's causing that weight? And I'll explain this more when I get back, but what's causing that weight is the Earth. And I'll be very brief. Gravity is this strange phenomenon where, for whatever reason, any object with mass, so any object you know of, anything with atoms, anything that's made up of particles, has this strange attraction to one another. Now, essentially, you need to have a lot of these particles together to be able to notice this gravity. So the Earth puts this force of gravity onto the block. Now, according to Newton's third law, there is an equal and opposite reaction. Equal and opposite reaction. So the block is actually putting a force back onto the Earth. And the Earth also does that to the table. The table has weight, right? So there's an FG going back and forth as well. I'll put it over here so it's not as confusing. So let me clean that up. So over here. So this is my system schema for these objects here. So I am going to now I'm going to zoom in on one object. So this is called a system schema because anything that's causing forces on each other need to be involved. Now, I can include maybe the air, or I can include, there's not much to include here, but let's just say the air, or maybe the table is touching the ground, or the ground is touching the floor, and the floor is touching the Earth, eventually. So let's be very clear. The Earth is not like the dirt outside. The Earth, think of the Earth as more of like that metal ball that's inside of the center of the Earth. So the Earth, full of iron, full of nickel, it's a very dense object, very far beneath our feet. There's so much mass there, that's what's pulling us down. So when I say Earth, I don't mean the ground or like the dirt or whatever. I mean particles way, way, way beneath us that there's so much of them, they pull down on us. Hopefully that's not too confusing. I'll try to clear up anything in person if you have questions on that. So, all right, this block, I'm going to zoom in and I'm going to put whatever forces appear on this block onto what I call a force diagram. Now, a force diagram, just keep it simple. Whatever your object is, it's going to be a dot. Let's start with gravity. I always start with gravity. Gravity always goes one direction. It goes down. FG. Alright. Well, I only have one other force normal. Now, I have it drawn to the left here. The system schemas, they're not directional. So even though like gravity looks like it's going up, it's always going down. It's always going to the center of the Earth. Normal force is going to be going up. So, this is my block. It's experiencing these two forces. You may notice these guys look like they cancel each other out. This is what we would call balance. We'll talk about more about that in the next few units, but that's what we have here. All right, my time, I'm doing pretty decent on time. But what I will probably have y'all do, I'm probably going to stop this video here. I'll let you guys do let's do the block and the ramp. And then we'll also do this one with the 2 strings. So we'll do this one with the 2 strings. And I'll probably do this one really quickly. But for y'all, do interaction 3, interaction 6, and we'll meet up next video, and I'll show you how I'm going to work through it.